Common source stage with resistive load. So this is circuit for common source stage with resistive load. It has one RD, that is drain resistor. Then this is gate of MOSFET. This is N channel MOSFET, and source terminal is grounded. So the voltage between gate and source is VGS. So V out DC is equal to VDD minus IDRD. So V out DC, that is this voltage. So law applied at this node. So KVL is applied at this node. So V out DC is equal to VDD minus voltage across RD, that is ID into RD. VDD minus IDRD minus 0. So the loop is like this in a clockwise direction. Then this is equation for V out DC. Then VGS is greater than or equal to VL, that is load resistance. Then as V in crosses VT, so as V in, so this is V in, as V in crosses VT, so that is this value, V out is greater than VG minus VT. V out becomes greater than VG minus VT. So this is graph for the resistive load, common source stage with resistive load. Then this is saturation region. This is linear graph. So VDS is equal to VGS minus VT, that is drain to source voltage. Now this is small input signal circuit. So small signal circuit for that common source stage with resistive load is this. So V out, now V out is equal to minus GM. GM is transconductance. VGS RD. VGS, so this is VGS and this is RD. As VGS is equal to V in, that is gate to source voltage is equal to V in. So minus GM into VGS into RD. So RD is this. Now VGS is equal to V in, we know that. Then V out is equal to minus GM V in RD. So replacing VGS by V in, we get minus GM V in RD. Then AV by A in, that is output voltage gain divided by AV in, that is input voltage gain, is equal to minus GM RD. So minus GM into RD. So V in goes here, AV by A in. So minus GM RD it is. Then it is equal to minus GM in bracket, in square bracket, RD parallel to R0, because R0 is internal resistance. So RD parallel to R0. So minus GM RD parallel to R0 is equation for output to input gain. So this is about common source with resistive load.